Hello everyone, it's Anumodit Kumar. Welcome to Key Concepts. In today's session, we are going to discuss about the startup setting. Before startup setting, let's recall what are the key concepts that we have discussed in our last 2 to 3 videos. So initially, we have discussed what is the requirement of tuning the different motors. Then in the next lecture, we have discussed about the how to acquire the motor electrical parameters. Then after that, we have discussed about the ISD settings, how to select different values and what are the major criteria that is related to select the different ISD values. And then we have discussed the PSD settings and what are the like how the PSD or like what are the different startup methods that is available with the BLDC motors. And that we have went through the Alize and Go method, and then we have discussed about the PSD. PSD is utilize the inductive sensing method, how inductive sensing methods actually works. That all details we have discussed in it, and how internal like you could say the algorithm work in it. So we have discussed all those points in our last video. If you're not able to watch that video, please go ahead with that. First you watch these videos, then you can come and continue this video. Okay, so more on the way the sequence, the same way whatever the sequence we have following till now. We have completed the motor acquiring data before startup setting. PSD also we have completed. Now in today's session we are going to start with the startup setting. Like the motor usually utilizes two different methods. First is Alize and Go method, another is a PSD setting or PPSD method. So PSD methods utilizes when the Alize is not required. Alize always sometime in some application it will go back, so it's not be like sufficient to start the motor. In that cases, we need to select the Alize and Go method. Okay, and like if you require getting a back is acceptable to you, then you go with the Alize and Go. If you're not acceptable, then go for the PSD method. Okay, so when we talk about the time, it also always like the Alize time is a period of the certain voltage with the current flowing from phase W to V and applied to the motor to force the rotor to some certain position. So this particular time always be selected based on the motor like different applications. In some cases, if your motor inertia is very higher, you need to select the higher time duration. So your motor will aligns perfectly, or you can say your motor will start perfectly. If you are selecting very less time duration, in that time it may be possible will go for the more like it will went to the startup failure. Okay, so we need to select this particular time as larger as possible. Okay, but not too larger also, because if you are selecting this value to like with a higher value, that it might be possible it will like take more time to start. Okay, so we need to select the like mature value or like a proper value based on your physical appearance of the motor, like. Okay, so that's totally the dependent factor. So as we have two different graphs, if you have seen like we have selected two different values like 0.67 second and another value is 2.7 seconds. So these two different values, as you can see, like it's providing the current to like settle in that particular duration. So in some application we are selecting lesser value, in some application you need to select the higher value. If you are selecting higher value, it will also slow the operation, but more or less it will provide you the smooth startup. So in some usually if you're in ceiling fan application, we always try to go with the PSD setting. So we are not, this particular setting is useless for us. So just leave it. If you're not selected, whatever the default value coming with the different manufacturer ICs, so just keep it. That's not an issue for you for ceiling fan application. If you're going for some other applications, then you have to select these values. It depends on like if you're selecting the, so this particular feature only enable, or selection only enable when your device is coming up with the Alize and Go method only, right? Hope you understand. So the selection criteria always be based on if the motor having the bigger inertia, it means it required longer time that we have discussed. The first position time of the motor is always be depends on the inertia. If you're that's totally with the inertial having concern. And if your motor inertia is higher, if you're selecting lesser time, then your voltage is very less, then it might be the failure of the startup. So get some basic idea of the FPT. So if your motor force position time is shorter, okay, and the inertia is lower, the motor will start smoothly. Okay, so the selection is you have to select the lesser value. if your inertia is lesser. If your inertia is higher, if you are selecting the shorter value, it may be possible a startup failure is happening. Okay. In the other condition, if your force position time is longer and if your inertia is less, but the motor will start smoothly, but it will slow. It might be a slow start, slow startup. In another condition, if your motor inertia is higher and you are selecting the higher value, the motor in that case also the motor will start smoothly. So these are the observation that I have experienced when I am doing these activities. So let's consider big guideline, but all that's not actually a thumb. These are just a thumb rule. So I whatever the like key you can say the observation that I have went through. If you are going for tuning, you can consider it as a reference. Next, consider to be the like open loop or open loop acceleration or startup acceleration. Some manufacturers they are considering to be the open loop acceleration. Some manufacturers they are considering to be the startup acceleration. So what actually it means? When a motor is like you can say the PSD activity is done, now your motor is capable to start. So in that time we have to provide some acceleration to start. So same way I have discussed in our very first lecture, and that I have taken example. If you consider one bike having with two gears, two different gears. Once you like the PhD just like to pick up your bike, and once your bike is start just pick up and start running, so you have a throttle. So just like that you have a throttle, and if you increase the throttle, your bike is start running in a forward direction. The same way, this is neither just like a throttle of your bike. So startup acceleration just like a throttle. If you increase your throttle, your motor is pick up first, and like then it start rotating. If you have selected the lesser startup acceleration, your motor will start slowly. If you are selecting the higher acceleration, startup acceleration, your motor will start fastly. So this is the difference, and that also affects your startup. If you are selecting the lesser acceleration value and the motor inertia is also lesser, in that time the smooth startup is going to happen. If your startup acceleration is lesser and if your motor inertia is higher, then in that case the startup acceleration is also going to start smoothly. If your startup acceleration is higher and your heavy motor inertia is less, then it may be failure of your startup. Okay, in the same way the higher acceleration and the higher inertia, in that case also the motor will go face the startup failure. Okay, now the next this is a very interesting part. If you till now your motor is running on open loop acceleration, okay, or a startup acceleration, just like a bike. Your bike is running in a first gear. Is this possible? You are going to achieve very high speed with your first gear? The answer is no. So what you need to do, you need to change this operation to the closed loop. So the first question comes in mind, like what is the meaning of open loop and a closed loop? So open loop, as we have discussed, like and we already seen these points, like when we are selecting the open loop or a closed loop. So open loop, it means like just like open loop control system is just a one way, you can say, the operation. It's not having any closed loop. Okay, in closed loop application or you can say operations, we have a feedback. Okay, so in the open loop we are not taking back EMF as a consideration. Okay, and when these motors are switched from open loop to closed loop, then we are considering our back EMF. Okay, and as a feedback, and we are based on our sensing the back EMF, we select which we sense which speed or what is actual our motor is like position. So get a sufficient back EMF sensing, we need to get motor RPM to some certain extent, and once it reaches to that particular RPM, in that time you are sensing your back EMF value in a very proper way, so now you are capable to switch your motor operation to the closed loop. If you are switching your motor application in a very higher, you can say the RPM compared, like just mechanical RPM, consider 100 RPM, if you are switching it, then it's okay. If you are switching it in a very lesser value, then it might be possible your back EMF value sensing is not that much good. so motor will not able to switch. So in that time very high current will go and the motor will go with the overload protection. If you are switching this particular threshold open loop to closed loop in a very higher RPM, in that case also it may be possible motor will trip or it will enable the overload protection, right? The general idea which we are going to get, okay, so that is always be 1/3 of the maximum speed, and that is actually electrical speed, that's not a mechanical speed. Let's see the one basic formula. This is you can say the electrical frequency formula. So N is equal to the number of poles, okay, number of poles of the motor. In ceiling fan application we have 16 poles, okay, and this is the S is the motor mechanical RPM. Let's assume some value, okay, and F is electrical frequency, we have already discussed. So let's take some example. This is a very interesting one, please try to understand this part. Let's take the example of some motor which having a 370 RPM, right? This is a mechanical RPM, so it's rotating, so it means like in 1 minute it will rotate 370 times, right? And we have selected some motor which having the 16 poles, right? So we just need to find like what is the electrical frequency of this particular motor. So N is equal to 16, right? And this is the formula 120 divided by 120 multiply by S, that is actually in RPM, okay. So if you calculate this value, what you are going to get, you are going to get the electrical frequency is 49.33 Hertz. You may calculate this value by using your calculator, okay. So now what we need to do, we have 1 Hertz is equal to 60 RPM. That's the general formula, okay. And when we talk about 49 Hertz, it means we have 2959.8 RPM. Round figure you make it 2960 RPM. And that is electrical speed. So what we have discussed in our last lecture, when we synchronize your motor, if your motor is running with the 370 RPM, it means you electrically in 1 minute you are sending 2960 electrical cycles, okay. Just like if your motor is rotating in 1 minute, you are sending this particular cycle, this is considered 1, so it will be like almost how much, 2960, okay, cycles that you are going to send in 1 minute. When your motor is rotating at in 1 minute, your motor is rotating, you can say 360 times, okay. So what actually it means. So threshold values usually prefer to go with 1/4, okay, of this particular value. So that is comes nearby 740 RPMs. In the same way, we are also be selecting value in the between these two range. So usually this particular value to this particular value. So more or less that always vary from in some application you can go below. That's not an issue. But you have to see the tripping and other points. If it is working fine, that is okay. So usually for ceiling fan application, if your motor having RPM is the motor pole is 16, if your RPM is 370 RPM, then what you need to do, you need to select your values between 740 RPM to 987 RPM. Okay. So hope you get the basic idea. So these are two different graphs that I have taken some from manufacturers, okay. So if you selecting the 1536 RPM, then you're going to get this type of graphs, okay. If you are switching your open loop to closed loop acceleration at some higher value, then it might be possible you're going to get this graph. So always to prefer to follow the value, the range of 1.3 of electrical between these two value 1/4. So always try to get the middle value of this one, so your motor will operate perfectly. Okay, the one more point is there key the open loop current. So open loop current, what actually it means, like when you accelerate your motor, okay, so it required some certain amount of current to operate the motor, and that particular motor operation, that depends on which value your open loop current that you're going to like select it through the tuning. So if your motor inertia is higher, you need to select the open loop current value must be higher. Okay, and more or less some application, open loop current and Alice current both are comes with the same register value. So both values need to be selected in such a way that motor will start perfectly, and that's all. The selection also depends on like if you're selecting very higher value, it might be possible that your motor power, like whatever the power supply that we have selected, that is not capable to provide it. So, and whatever the customer preferences that they are asking for, so that also depends like which value you need to select, so it will operate perfectly, and in the while taking some consideration the startup time, and the same way you need to select right value according to your power supply as per the customer preference what they are actually asking. Okay, so that's also a major factor to select these values. Okay, so I have taken some graph from some manufacturers. Okay, so in that, if you are selecting 1.2 ampere, so it will actually provide your, like the magnitude of this one is 1.2. Okay, not PSD. PSD is another one. PSD, like the current threshold that we have seen in PSD, that's totally different one. This is in open loop concern, so it's now the motor is running in open loop concentration, like open loop acceleration. So you need to select some certain value, so it will operate the motor. So in that 2.4, so as you can see, the amplitude of this one is higher compared to this one. So higher value always be preferred, okay, for open loop consideration. So in that ceiling fan application, I always going to go with 1.6, in some cases 2 amps also, but 1.6 amps is always preferred. So try to prefer this one. Alias current also we comes in the same way. If you are having the bigger, you can say the torque. Okay, if you're having the bigger torque, then you have to select the bigger value. Okay, that will allow you motor to rotate in the same way. But more some cases, so both in some manufacturers they are separately giving these two options in register options in your GUI setting. In some cases they are putting in the open loop concern only. So always as a thumb rule concern for the Alias current and the open loop current, always go with the higher value and see which value suits as per your applications. Okay, so some guidelines for the open loop and like you say the Alias current. So if you're if you're selecting the open loop or Alias current value is lower and your inertia is lower, the motor will start. But that also depends on the you can say the motor. We can't say that's the thumb rule for that. So that's also depends. And if your motor the open loop current is lesser and your motor inertia is higher, so it may be possible motor will not start perfectly, or else will the starter failure is happen. In next case, if your open loop current value is higher and the motor inertia is lesser, in that it might be cause a motor starter failure. Okay, in some cases, but that also depends on the motor tuning. If your motor is tuned perfectly, then it might be possible, it will not. But that depends. That's why I'm saying it's not a single statement. I'm not able to say, because a lot of different factors that are affecting this particular point. So in other, if your motor open loop current value is very higher, and if your motor inertia is also higher, in that case motor will start perfectly. So hope you're getting some basic idea how to select these values, and okay, so you're these are the basic guidelines usually you can follow for lesser you can say the open loop acceleration open loop current. If you're selecting the lesser value, okay, if you're selecting the lesser value, you're going to get the smooth soft start. Okay, and if you want to go for the fast start, you need to select the higher value. Okay, so usually manufacturers these having this value from 0.2 amps to 2 2.4 amps. These are the usual value that usually referred to. Okay. Now we have switched our, you can say, the motor operation to the closed loop. Now you need to again increase your throttle because while choosing this one you reduce this one, you can say the concern of the RPM. So what you need to do, you need to again select the closed loop acceleration, so that will rotate your motor. So closed loop acceleration, when your motor is now operating in a closed loop, so you need to provide a closed loop acceleration to the motor. Okay, so closed loop acceleration are basically the different manufacturers can provide different like you say the parameters to these values. Now if you're selecting the like you say the closed loop acceleration is value is you can say the smaller one. If you're having the smaller acceleration value, then it means that your motor will start smoothly. If your acceleration, you can say the if your the higher acceleration, it may causes the open loop acceleration or motor operation failure. Okay, and it will operates the overcurrent protection. Okay, so while selecting this value, you have to very much you can say the conscious about the selecting the right value. Always try to go with the lesser as possible RPM. You can for acceleration for closed loop. Okay, so for some application we go for 330 32 multiplied by VCC, okay, per second. Some application and some manufacturer they give in this format. Some other applications they give in frequency. So that depends. But always try to get this value as low as possible. Okay. This is some example when you rotate your motor. Then already I have discussed like before this one. This one is open loop acceleration. This one is closed loop acceleration. Now once the motor reaches the desired RPM, okay, then let's assume this one is 100 mechanical RPM. Okay, now it's reach and it reaches to 70 RPM. Just to take some example, the maximum RPM is for this particular motor is 370. You can say RPM. Okay. And now once it reaches the RPM, it will go to the steady state transition. So hope you get the basic idea about the motor tuning. Okay, please, if this is example of the if your startup is get fail, if you are selecting very higher value, then it might be possible you are going to your startup the motor operation get fail and it will trip and it will enable the current overcurrent protection. Okay.